Bismillahirrahmanirrahim. Assalamu alaikum. Today we are going to start sequence and series. Now let's define it first. A sequence, an ordered set of numbers formed according to a definite rule, is called a sequence or progression, and the individual members are called terms or elements. Now if there is a pattern of numbers, you can say number like 1 2 3, and you can see that they are in a definite order. That is, there is 1 2 3 means that is the next numbers comes from adding 1 1 2 and 3. Now you see that next number is coming by adding 1, and this is 2 plus 1. So if there are numbers in a definite or in any order, they can be in multiplication or they can be in a subtraction form. If they form a definite pattern, then it is called a sequence. Now that's defined in mathematics way. This is the simple general in an ordered set of numbers. We are writing in sets formed according to a definite rule. So there should be a definite rule, then we called it a sequence, because sometimes if there is no definite rule in the pattern, then you cannot put it into in the sequence. In mathematical way, we can say a function a from n is to r or complex number c is called sequence, where n is natural numbers and r is a real numbers and c is complex numbers respectively. Now for any n belongs to natural number, if there is a number n belongs to natural and a belongs to natural number, and that gives you a function to r or c, maybe it will be a possible c, that is complex number, it is called the nth term of the general term of a sequence. Because if there is a pattern, then there should be a rule, and that rule assign you that make it as nth term. So you can make a general formula, or that is called n term for each sequence. So you can put values of n. Suppose you put n is equal to 1, then your first term will be appeared. And if there is, suppose this is a tn is equal to n, that is nth term is n. If you put n1, your first term will be appeared. If you put 2, second term will. So n should be from 1 2 3, and that is from first term to second term and so on, and n must start from 1, not from 0, and it is called the nth term of the general sequence. We usually write an as an, sometimes we write this in nth term as an, and in definition we have told that nth term of this or particular terms we put value of n as an. Also we can also write it like in an form, where n belongs to natural numbers. So a are natural numbers. Now you can write these are the terms of a sequence a1 2 and so on, and we can also write t1 the nth term of t1 t2 t. There is another. So there are some examples, like you can see the 1 2 3 4, where a n is equal to n. This is your nth term. If you put n is equal to 1 appear. If 2, I have already told. Now 5 9 13, there is a definite rule, a n is 4n plus 1. If you put 1, then you will get 5. If you put 2n, you will get the second term, and so on. And there is more examples for it. So this is the sequence. Sequence is actually, we can have a definite rule in it. That is why now I want to tell you, if you add 1 plus 2 plus 3, you are adding sequence, then it is called series. Okay, now we will discuss series in later, but first we are going to take questions for our exercise, that is find the nth term of the rule formation of each of the following sequence. Now we have to find the rule. Rule means, that is, this is your question 1, sequence and series. Now what will be the rule? Now it means that what will be the nth term. Now there is a formula for nth term. If you will learn in future if you recognize which type of sequence it is. But we can also, without knowing, we can tell our understanding. Now you can see that first part, you want to find the nth term of it, and there's, you don't know the type of sequence that is. Now you can see that this is 2 4 6, and you can see that next term will be 8. It means it is a 2 of table. And now you can see that pattern, 2 multiply by something, you have 2, and inside 2 multiply by 2 you have 4, and then 2 multiply by 3 you will get 6, and so on. In this pattern you will continue. It means this, if you put here 1, then this sequence generated is 1 2 3 4. So this is a constant term. So our nth term will be, because this is a varying, and we always make n term by supposing that n is 1 2 3. Where is changes happens, that will be n. So it will be 2n will be the nth term of this sequence. So this is the way we can recognize the pattern or understand the pattern. Now let's see the next example. Now here we have 1 square, 2 square, 3. Now where are changes occurs? It will be at the basis. So n could be 1 2 3, and maybe first term, second term, and so on. So I can write like n square. So this is its nth term. Now you can check it putting an. We also sometimes write en, but an is our symbol. And put 1, you will get 1. If you put 2, you will get 2 square and 3 square, and so on. So it is term our correct. Now next question, see that 3 9 27 and so on. It is also infinite sequence. Now we want to find out the pattern. Now let's see, I observe that 3, this is 3 square, and this is 3 cube. It means I have made the correct pattern. Next term will be 3 or 4, because you can see that multiply of 9 is going on. 3 multiply by 3 9, and 9 multiply by 3 27. So you can see that 3 square, 3 cube, and 3 4, and it will continue. It means where are changes occurring. Now you see 2 3, probably there will be a 1 here. So our nth term will be, because 3 is fixed term you have to take. Now where is changes occurring? At the top. So top is n. So this is our nth term. Now let's see the next part. You can see that 1 upon 2, 2 upon 3, and 3 upon 4. Now watch closely. Now you see that 1 2 3 at the top. It means top is n. What about the downward? Now 1 2 3 at the numerator or upper part, you can observe it, it is an n. Now what about the 2 3 4 5 and so on? Now you can see that it is also n, but there is only first term is missing, and first term is 2. So if you add 1 plus 1, so that will be your term, and it 2 plus 3, 2 plus 1 will be 3, and also 3 plus 1 will be 4. So you can see that there 1 is fixed, and 1 2 3 is going on. So I can write my nth term as n plus 1. So now combining this, because in denominator we have 2 3 3, and numerator we have, this is simple n. So our nth term will be an will be n upon n plus 1. So this is the way we confirm the terms. Now take another questions. This is just different question, and observe it. This is your part 5th. We have 1 minus 1 upon 3, 1 upon 9, and minus 1 upon 27. Now you can see that there is alternate negative signs. So if I check again, this term is the same thing. This is again 3's table, that is you 3 squares or other things. Now you can make it pattern like this: minus 1 upon 3, 1 upon 3 square, and it is a positive, and minus 1 upon 3 cube, it is a negative. So you can see that these are negative. Negative means that your each term comes positive and negative. It continues in this way. Your terms coming negative and positive. So it means square makes things positive and cube makes negative. If there are odd terms, your answer will be negative. So I can write like this: 1 minus 1 upon 3. I am taking the bracket. Now 1 upon 3 square, and similarly minus 1 upon 3 cube. Now you can see that this is a just correct way, because when you make that will be 3 square positive, and when you come to that will be minus 3 cube, and in the now you can see that pattern is changing. This is a constant term but in alternate signs, and it depends on the powers, and power is 2 and 3. It means this is your n, 2 and 3. Now before 2 it will be, there will be a 1. Now what about the first term? Now first term, you can see that there is no power here, and you cannot put here, and you cannot also put 0, because you need a first term. So I will make it like this. We have already a definition: x square is equal to having power 0 is equal to 1. So I will write it 3, make it sequence, and write power 0. But remember that we don't allow n to be 0. So what we will do, I will do one technique like this. I will make it 1 minus 1, and then minus 1. I have already made 1, and 1 upon 2, 1 upon 3 square, and so on. Now you can see that this is 1, this is 1 again, and this is 1. Now what will be your 1, 2, 3? Now you can see that n minus 1, because this n you have to take as n. And what about here? If you take n, there is only a 1. So what will be the answer here? Maybe it is answer 0 or something. Then what will we do it? What will be our answer? Now you can observe that if you take n minus 1, and n is 1, when you put n is equal to 1, your answer will be 0. When you put n is equal to 2, your answer 2 minus 1 will be 1. So it means this 1 can be written in the form of n minus 1 and n minus 1, and n minus 2 will give you 2. So it means our pattern will allow us to write this term as n minus 1. So now you can check, put 1, you will at first term 1, then 2 minus 1, your first term 2 comes, and 2. So this is the direct method to find out the sequence pattern of this sequence. Now there will be a formulas in further. Now the last part says 1, 8, 27, 64. Now observe these terms. Now 1 is still 1 here. And what about 8? How about 8? What we can make 8? 2 square, 2 cube, or anything. I can make it 2 cube, and I can make it 3 cube. I can make it 4 cube. So what our pattern is? Cube is constant, or I can write for formality cube is here, because 1 nothing matters. So it means our nth term will be n cube, because n is not fixed. 1, 2, 3 n is, and power 3 is fixed. So these are the nth terms. Now let's move to our next question. I will do it little. Question 2 says find out the first 5 terms of the sequences with the given. These are very easy. In these questions you have given nth terms and you have to find only 5 terms, first 5 terms. Now take the first part, 2n plus n minus, put n is equal to 1, 2, 3. Now I am taking the first part. Question 2. First part. Now I have to find first 5 terms. 2n, 3, n plus 1. Now put n is equal to 1. You have 2 multiplied by 1 upon 3 and 1 plus 1. That will give you 2 into 2 into 1 upon 3 is equal to 4 upon 3. Our first term is 4 upon 3. Now put n is equal to 2. You will get 2 multiplied by 2 upon 3, 2 plus 1. This will be your second term, 4 upon 3 and multiply by 3. Second term is 4. Now the third term. Put n is equal to 3. 2 multiplied by 3 upon 3 and this will be 3 plus 1. 3, 2, 4, 8. Our term is 8. Now n is equal to 4. You have to put 4, 2 multiplied by 4 upon 3 and 4 plus 1 is equal to 5. So 8 upon 3 multiplied by 5 is 40 upon 3. This is your answer, 40 upon 3. So now you can also find out the fifth term yourself. Now take another example, you can understand it better. I am taking the last part, 6th part. 1 upon 6 n plus 1. 1 upon 6 n plus 1 and second term is given 2n plus 1. Now you can see, put n is equal to 1. N is equal to 1 will be 1. Simple calculation of mathematics. 1 plus 1 and 2 multiplied by 1 and plus 1. This will give you, this is your 1 upon 6 and 2 and this will be 3. Now 2 ones are 2, 2, 3. Now 3 ones are 3, you have 1. Your first term is 1. Now similarly you can find other terms by putting n is equal to 2. When you put n is equal to 2, your answer will be 1 upon n is equal to 2. 1 upon 6 multiply by 2, 2 plus 1 and 2 multiplied by 2 plus 1. That could be a fraction or anything, but I can see it can be cancelled out. 3 and 3 multiplied by 3 and this will be 4 multiplied by 5 and 9 5s are 45. So these are the way you can find out the term. Now similarly one of the question of yours says that question 3 says, let me see the question 3. Question 3 says that find the sequence by using t1 is equal to 2. Now this t1 means that is the first term, that is your first term is t1 and formula is given, you have a tn plus 1. Now let me write the formula. Question number 3, you have tn plus 1 is equal to n plus 1 and tn. Now you have to find t1 is equal to 2. Now how you will find t1 is equal to, put n is equal to 1. You have t1 plus 1 and n1 plus 1 and tn means t1. Now you have t1 is given, so t2 will be there. 2t1, t1 value 2, so t2 will be 4, and similarly t3. Now n, put n is equal to 2, so that will be t2 plus 1, and you have a term n plus 1, 2 plus 1 and t2. Now t2 term is the top term 4, so use this term 3 multiplied by 4, you have t3 12. Similarly, put n is equal to 3, you have t3 plus 1 is equal to n plus 1, 3 plus 1 into t3. Now t3, you observe that it is 12, 3 plus 1 4 and multiply by 12 and it will be 48. So sequence is, you have to find sequence. First term t1, t2, t3 and so on. We will continue by the formula. T1 is 2, t2 we have find 4 and t3 we have find 48, 12 and t4 we found 48, and it will continue. This is the required answer. So now we have learned the definition of sequence, and we find the general way or a rough way to find out the, without any formula, find how to generate a nth term of a sequence. Okay, Allah Hafiz.